Imagine floating in space, completely alone. In front of you is a perfect black sphere. No light, no surface, no sound. Suddenly, stars behind it begin to bend. Time around you starts slowing down. Your body feels normal, but to the rest of the universe, you are freezing in time. And then comes the most terrifying part. You don't hit the black hole. You become part of it. But what really happens if you enter a black hole? Will you die instantly? Will you be stretched forever? Or could you actually survive and see another universe? Today, we're going to find out. Welcome to Gravity of Singularity, where we explore the deepest mysteries of space, mind-bending discoveries, and the most extreme objects in the universe. From black holes to cosmic missions, we bring the universe closer to you. Now let's begin our journey into the darkest object ever discovered. First, let's understand, what exactly is a black hole? A black hole is a region in space where gravity is so strong that nothing can escape. Not even light, that's why it appears completely black. But here's the surprising part. Black holes are not empty holes. They are actually extremely dense objects. Imagine compressing the entire sun into a ball the size of a city. That's how dense a black hole is. Question for you. What creates something this powerful? The answer lies in the death of massive stars. When a star much bigger than our sun runs out of fuel, it explodes in a massive supernova. What remains collapses under its own gravity. It keeps collapsing, smaller, denser, until it becomes a singularity. A point of infinite density. This singularity is surrounded by something called the event horizon. This is the boundary of no return. Once anything crosses it, escape becomes impossible. Not even light can come back. That's why black holes are invisible. We can only detect them by their effects. Now let's look at some real black holes discovered by scientists. First, Sagittarius A. This is the supermassive black hole at the center of our Milky Way galaxy. It has a mass equal to 4 million suns, and in 2022, scientists captured its first image, meaning we now have real proof of its existence. Second, M87. This black hole is absolutely massive. It is 6.5 billion times the mass of our sun. This was the first black hole ever photographed in human history. Think about that. We captured an image of something that doesn't even emit light. And then there are stellar black holes. These are smaller black holes formed by dying stars. Thousands of them exist in our galaxy, and scientists believe there could be billions. But now comes the most important question. What happens if you fall into one? Let's imagine you are in a spaceship approaching a black hole. At first, nothing seems unusual, but slowly, you start noticing something strange. The stars behind the black hole appear distorted. Why? Because black holes bend space itself. This effect is called gravitational lensing. The closer you get, the slower time moves for you compared to others. This is real science. It's called time dilation. Question: does that mean time travel is possible near a black hole? In a way, yes. If you spend 1 hour near a black hole, years could pass on Earth. Now imagine your friend watching you from far away. They would see you slowing down, and eventually freezing at the edge. You would appear stuck forever. But from your perspective, you continue falling normally. This is where things become terrifying. You finally cross the event horizon. At this point, escape is impossible. No turning back, no rescue. Now gravity starts pulling harder on your feet than your head. This stretches your body. This process is called spaghettification. Yes, real scientific term. You are stretched thinner and thinner. Eventually, your body would be torn apart atom by atom. But here's the strange part. You wouldn't instantly feel it in supermassive black holes. Because the gravity difference at first can be small, you might actually cross the event horizon without noticing immediately. Now question: what would you see inside? The answer is, no one knows. Because no information has ever returned. But physics gives us some possibilities. Everything leads toward the singularity, a point where space and time stop behaving normally. The laws of physics break down. Reality itself becomes unknown. Scientists have uncovered discoveries about black holes that completely changed our understanding of reality. For a long time, we believed black holes were simple cosmic monsters, swallowing everything and giving nothing back. But that assumption was wrong. First discovery, Hawking radiation. In 1974, a brilliant physicist named Stephen Hawking made a shocking prediction. Black holes are not entirely black. They actually emit tiny amounts of radiation. This phenomenon is now called Hawking radiation. But how is that even possible? If not even light can escape a black hole, how can radiation come out? The answer lies in quantum physics. Space is not truly empty. Even in a perfect vacuum, tiny particle pairs constantly appear and disappear. Normally, these particles annihilate each other instantly. But near a black hole's event horizon, something strange happens. One particle falls in, the other escapes, and to an outside observer, it appears as though the black hole is emitting radiation. Over an unimaginable amount of time, this process causes the black hole to slowly lose mass. Trillions upon trillions of years later, a black hole could completely evaporate. In its final moments, it may release a burst of energy. Meaning black holes are not eternal. Even they have an end. Second discovery, black hole mergers. In 2015, humanity detected something extraordinary. For the first time in history, we detected gravitational waves. These are ripples in space-time itself. They were caused by two black holes colliding billions of light years away. Imagine that, two invisible giants, each heavier than dozens of suns, spiraling around each other, faster and faster, until they crashed together. When they merged, they released more energy in a fraction of a second than all the stars in the universe combined. And that collision sent waves across the fabric of spacetime. Those waves traveled for 1.3 billion years, before gently passing through Earth. The detection confirmed a prediction Albert Einstein made 100 years earlier. It proved that space itself can ripple. Third discovery, black holes shape galaxies. Today, scientists believe that nearly every galaxy contains a supermassive black hole at its center. Including our own Milky Way. These black holes are not just destroyers. They act as gravitational anchors. They regulate star formation. They influence how galaxies grow and evolve. Without them, galaxies might not form in the structured way we see today. Which means something extraordinary. The very force that can destroy stars may also be responsible for creating the environment that allowed life to exist. Black holes are not just cosmic villains. They are architects of the universe. Now comes the question that stretches imagination beyond its limits. Could black holes be portals? Some theoretical models suggest that inside a black hole, instead of a simple singularity, there could be a bridge. A tunnel connecting two distant points in spacetime. This concept is known as an Einstein-Rosen bridge, more commonly, a wormhole. In theory, one side could be a black hole. The other side, a white hole. A white hole would be the opposite of a black hole. Instead of pulling matter in, it would push matter out. So what if falling into a black hole doesn't mean destruction? What if it means passage, a shortcut across galaxies, or even into another universe? Right now, this remains purely theoretical. We have no evidence that stable wormholes exist. Most calculations suggest they would collapse instantly. But physics hasn't ruled them out completely. And that possibility alone changes everything. Because if wormholes exist, then the universe may be far more connected than we ever imagined. Black holes are the most mysterious objects ever discovered. They bend space, they slow time, they swallow light, they reshape galaxies, and perhaps they connect realities. If you were to fall into one, from the outside, you would freeze at the edge forever. Time would stop for you. The universe would move on without you. But from your perspective, your journey would continue. Toward a place where the laws of physics break down. Where space and time lose meaning. Where our current understanding of reality ends. And maybe, just maybe, that is where the next great discovery begins. Because every time humanity believed it reached the edge of knowledge, it discovered something greater beyond it. Once, black holes were only equations on paper. Today, we have photographed them. Tomorrow, who knows? Perhaps one day, we will truly understand what lies inside. Until then, black holes remain the ultimate cosmic mystery. If this journey expanded your mind, subscribe to Gravity of Singularity. Because the universe still holds secrets we haven't even imagined yet. And we are just getting started.